Okay, Assalamualaikum and hi. So today we're gonna show you guys how to use this GeoGebra for function 2 plus x square from limit 1 to 2. So first thing first, we write the function fx equal to 2 plus x square. Then we write the function bracket f 1 2. So then we select the gx and we go to setting, style, and we set the line thickness to 3 and we set the color to black. Okay, next we write n and we go to setting, slider, and we set the minimum to 0 and the maximum to 2 pi. Next we write the surface bracket g and y-axis. This is how it works.
Assalamualaikum. Today we are gonna show you guys how to use GeoGebra for function 1 minus x square limit 0 to 1. Okay, first you need to write the function fx equals to 1 minus x square. Okay, second we need to write function bracket f0 1. Then we select the GS1, then go to setting, style, line thickness 3, and we set the color with black. Next we write n, go to setting, slider, we set the minimum with 0 and also the maximum with 2 pi. Then we write surface g, n, and also y-axis. Yes, that's it. That's our result.
First, consider the given function displayed on the screen. This function represents a curve in the Cartesian coordinate system. We define the interval of the function using the lower and upper limits on the x-axis, which are clearly shown in GeoGebra. The shaded region under the curve represents the area that will be rotated. Next, we identify the axis of rotation. In this example, the region is rotated about the x-axis. When the region under the curve is rotated around the x-axis, it forms a three-dimensional object known as a solid of revolution. As the rotation is applied, GeoGebra generates the surface of revolution. we can clearly observe how each point on the curve traces a circular path around the axis. This circular motion creates a smooth surface, which represents the outer boundary of the solid. Mathematically, this surface of revolution is related to integral calculus. The surface area can be calculated using a surface integral formula, which depends on the function and its derivative. GeoGebra allows us to visualize this concept, making it easier to understand how the formula represents a real three-dimensional shape. In conclusion, GeoGebra is a powerful tool for visualizing surface of revolution. By rotating a function about an axis, we can better understand the geometric meaning of integration in three dimensions.
Right now we'll be doing the question 4, revolve around the x-axis, y equals to 3x plus 3. Interval starts with 0 to 1. So let's proceed to GeoGebra. First off, we enter our function, which is 3x plus 3, and then we press enter, and then we put our next function, gx equals to function, but we use the function start value and end value. So for the function we put f, and then for the start value we put 0 and 1. Click enter. We can actually create a slider by initiating the values of n equals to 1, and then starting from 0 to 2 pi. And then for the steps, we put 0.01, and then we press enter. Next, we put surface. We choose surface, curve, angle, line. So for the curve, we choose gx. For the angle, we choose n. And for the line, we choose the x-axis. And now when we look at the graph, we can see it's finally revolving. We can revolve it by adjusting the n value. So as you can see, the graph, the shape is like revolving. So that is all for question 4. Thank you.
Assalamualaikum. My name is Muhammad Alim Barisham. My registration number is 227520. And my friend?
My name is Anik Najwa Iman bin Rosli. My matric number is 0379.
Okay. Today, we are from Group G. So today we will teach you how to use GeoGebra 3D calculator. So we got the function number 5, which is y equal to 3 minus x squared. The range is 2 until 3. Okay. So first of all, we need to put the function in the input. So fx equal to 3 minus x squared. Then enter. So the second one, we put the range. So gx equal to function f in the range. Enter. So number 3, my friend will explain it.
Okay, then we continue to the limit, and first of all we need to put n equal to 1. Okay, equal to 1. Then change the 0 to the change to the from 5 to 0, and the other one is 2 pi, because 2 pi represent 360 degree, so that we put 2 pi. Then continue to the next part is a equal to surface, okay, bracket, and g comma n comma y axis, and then press enter. Okay, then the product will form, the 3D product will form. It is the shape like a plastic cup that we use to drink. Okay, Adam, can you jiggle the 3D product for me? Okay, this is the product from our 3D part, and I think that's all from us for the function 5. Thank you.